thickness, volumes of various important subcortical structures. It's probably too early to make any really firm generalizations, but I think a reasonable working hypothesis is that you see the biggest effects in areas that are typically involved in executive function, emotion regulation, and language. Functional differences, striking functional differences that have been looked at the network level, as well as more traditional blobs, fMRI, where's the blob designs. We see differences in cognitive patterns of activation during cognitive processes, patterns of activation when people are processing emotional stimuli. A very sad generalization that can be made at this point about the data is that lower SES people activate the relevant brain areas less strongly to positive stimuli and more strongly to negative stimuli. That's true with your standard IAPS pictures for those of you who do this kind of work. It's true for emotional faces. It's even true for new mothers looking at pictures of babies. And if they're looking at pictures of happy babies, you get more activity in reward centers for the higher SES moms. And if it's looking at pictures of crying babies, fussy babies, you get more activation in the amygdala and other areas in the low SES moms. There are effects that you see early in life. We did a study imaging 1-month-olds, looking at volume of cortical gray matter. And to our surprise, we found differences. This was supposed to be the first phase of a longitudinal study where we thought we were going to see the differences emerge. It's called our attention to the importance of the prenatal period. And I mean, some of you are like, of course, the prenatal period. To me, trained in psychology, we sort of begin with the kid when they come out, But it turns out there's very good data from animals and humans showing that prenatal environmental influences shape the brain throughout life. So that's the picture at the most descriptive level, okay? And I am frank and humble about saying this is just descriptive, which is not the most exciting science, but it's the place you got to start. Let's see, Hewlins Jackson has a wonderful quote. He said, the study of the causes of things must be preceded by the study of the things caused. So I am kind of unapologetically saying, yeah, we've got a lot of descriptive research here, and we need that. We also have some more mechanistic, some research going on that looks more at SES and the brain in the context of the larger causal fabric of environment, life outcomes, etc. So there's the mediation question. Do these brain differences that we see account for outcome differences? Do they mediate the different life outcomes, mental health, cognitive attainment, etc.? And I don't want to overstate how much research we have to point to here, but there is research, and some of it fails to test mediation hypotheses and does not find mediation. Some of it tests them and does. Enough do that I think we can conclude, yeah, this isn't like starting a butterfly collection, right? Like, let's have pretty butterflies in our little display case. Let's find interesting, differences in brain structure as a function of SES. No, these differences do predict actual life outcomes that we care about. So that tells you something about the significance, not statistical significance, but real-world significance of these differences. That's the mediation question. And finally, moderation. Moderation refers to the effect of a variable, in this case SES, on a relationship between two other variables. So it turns out, not that anybody was particularly looking for this, but repeatedly people have stumbled over the fact that the relations that we find between brain structure or function and abilities or, psychological characteristics are moderated by SES. That is, if you want to predict somebody's ability or somebody's performance in a task by looking at their brain structure or function, you need to look at different things for higher and lower SES subjects. There's like a qualitative difference in the way people are using their brains at lower and higher SES. Again, nobody set out asking the question, I wonder if it's a moderator, but this does appear over and over. So that's interesting, and that's part of the emerging literature that I am, with apologies, not telling you much about. And then finally, I want to tell you that the questions that we really care about as scientists are the mechanism questions, right? Like what causes what? At what stages of development? By what pathways? And what specifically can we find out by studying humans and by studying animals? So animals don't have socioeconomic status, they don't have occupational prestige and things like that. But they have many of what we believe are the proximal causes of differences between low and higher SES people. Okay, so we can manipulate the stress that animals experience early in life, later in life. We can manipulate the cognitive stimulation, the variety of environments that they are allowed to spend time in, and so forth. So this kind of research has also been useful for trying to understand the mechanisms by which SES impacts the brain. In fact, there's even a more fundamental question in the what causes what department, which is, are these caused by environment at all? Are these brain differences caused by environment? Okay. So it is possible that it's genes that are causing both SES differences, less able to get and hold a job, less able to get an education, whatever, and that cause the brain differences. In which case, their correlation is sort of spurious in a way. It certainly means we can't just automatically say, talk about how SES causes these brain differences. But I will return to that because that is one of the issues that comes up front and center when we talk about applying the neuroscience of SES to policy. And not the current issue of Neuron, but the one before, has a review article that I wrote. So if this little summary has left you sort of craving more detail, more specifics, I can direct you to that, where I just tried to lay it all out. Okay. Right now, what can we say about the field of the neuroscience of SES? I don't want to overstate the certainty of the conclusions that I have just sketched for you. We've all learned our lesson, like replication, is important, and you can have really pretty findings that make perfect sense and then discover, maybe they're not true after all. Certainly some things have been replicated, and it would be astonishing to me if most of what I just told you doesn't hold up, but it is early days. The puzzle is still being assembled. I think the good news is that we know enough now to be able to formulate some really good specific hypotheses that can be tested with new research. So with that as your sort of thumbnail sketch of the neuroscience of SES, let me now turn to policy implications. There has been a lot said about the policy implications of neuroscience for the problems of poverty in the real world. And it has ranged from, super enthusiastic, this is, now we know what we have to do for poor kids, to super scathing about the science and its relevance, and scathing about the kind of social impact and politics of it. So I'm going to expose you to all of that in a bit. But first, just like we defined SES briefly at the beginning, I want to define policy, because it's a word, everybody uses it, nobody's quite sure what the other person means by it. It's not just law. It's not just government assistance programs, although it certainly encompasses that. It involves, kind of what's the state-of-the-art practice in family law and social work? How should we be teaching children, recommended educational methods? Medical practice, pediatricians are all over this, and they are thinking about, how and whether to change what happens in a well-child checkup, particularly for low-income families. It's relevant to legal practice. Bill and I were in the MacArthur Law and Neuroscience Network together for a while. I guess you still are. I was rotated out. But, conceivably during the guilt phase of the criminal trial and absolutely during the penalty phase, issues like, was this person changed significantly by their life experiences in a way that left them less blameless or completely blameless for what they did. And the opportunity to point to brain scans has not been lost on defense teams. And they certainly do come up in sentencing. Professional training. So if you are in a school of education, if you're going to medical school, to law school, what do we want to tell these newly minted or professionals to be about poverty and how it affects people? Could the neuroscience of poverty, or SES, could it change policy through just changing how new professionals go out into the world and practice their professions? So I just want to emphasize, this is not just sort of government programs. Policy has a broader scope than that. And certainly, people have claimed that neuroscience does tell us things that should be incorporated in all of these different aspects of policy. For example, in education, this is a best-selling book, very high up on the Amazon, scale for education books. It's been out for at least a decade, maybe more. This is a guide that was put out by the National Educators Association, a big national professional association of teachers. And it cites the kinds of research that I was just very rapidly reviewing. In pediatrics, as I mentioned, there are many guidelines for practice that incorporate, as you can see, the neuroscience of stress, of frontal lobe function, and so forth. This is an organization that trains adults, adult women, for kind of economic betterment. These are women who are poor, who are just having a hard time scraping by, and they use brain science to design new pathways out of poverty. Wow, who knew that our neuroscience could do that? And here's a executive summary of the kinds of things they talk about. You can see it's very much related to, you can see that neuroscience comes up here a lot. There's some more of the same. Okay, so can neuroscience really inform policy in these areas? You probably caught a little snarkiness in my voice as I was introducing this. I didn't quite mean that, but it's a little irksome, to sort of look at these things as a neuroscientist and say, what aspect of neuroscience is really being used here? Aside from sort of some terminology that sounds good. And there have been a lot of criticisms of this work. First of all, I'm sure many of you are aware of the sort of backlash against, neuromania. There's a very interesting book by Sally Satel and Scott Lilienfeld called Brainwashed, subtitle is something like How Mindless Neuroscience is Ruining Behavioral Sciences, something like that. There's a book by Raymond Tallis, which I think has neuromania in the title. Carlos Semenza has a book called Neuromania, just one word title. So there's a lot of backlash against this idea that we are really overreaching. Now, I think, in fact, that it's not neuroscientists who are overreaching in like the examples that I showed you a minute ago. It's people, it's consumers of the neuroscience, people who are more on the policy side and see it as a very persuasive talking point. But we'll come back to that. But one question is, I mean, we definitely get the argument that, look, this is bogus. This is just neuroscientists trying to claim they can explain everything under the sun. Another criticism that I think is worth thinking about, and I have to say myself, this was my view initially when I was reading stuff from the Center for the Developing Child, Jack Shonkoff's shop, on neuroscience, brain development, and child poverty and stuff, which is neuroscience is not producing any actionable new knowledge about poverty. It's telling us stuff at a sort of basic science level, but there's nothing that's coming out of any of that work that was illustrated with the quickly ramping up bar chart that tells you anything that you didn't already know from other sources, right? So this is a criticism. Look, it's not telling anything we didn't know. And one criticism is that it appears unlikely to tell us anything actionable, important in the near future, or in the future. One statement of this by somebody who, Hank really certainly knows, Bill may remember also, is Amy Wax, a law professor, who has a paper forthcoming with this great title. And, she basically argues there is nothing of value here, specifically, on several grounds. I don't know if the print there is too fine, but one of the points she makes, which is also made by Charles Murray, a prominent social scientist of the conservative stripe, he co-wrote The Bell Curve. He is very interested in sort of nature-nurture issues, meritocracy, and basically these people have said, look, if the effects are genetic, then if these effects that you're seeing in the brain are genetic, then what policy consequences could they possibly have, right? So first of all, that is a non sequitur. That is obviously false. Something can have a genetic origin, but be perfectly amenable to environmental treatment. Second of all, it's an empirical question whether these brain differences are genetically driven or environmentally driven. A question that is far from resolved. I'm collaborating now with Eric Turkheimer of the University of Virginia, a very terrific behavioral geneticist, and we are trying to use the twin data from the Human Connectome Project to sort out, genetic and environmental effects. So stay tuned. But there's lots of sort of circumstantial data from studies of behavior that look at, for example, adoption studies, that look at studies of the effects of poverty on siblings of different ages growing up in a home that has been poor for a certain period of the family's time, but not for other periods. And it turns out the impact on the child's, IQ, behavior, other things, is greater for the younger the child is. So you're controlling for the family, you're controlling for the genetics. There is no obvious way to explain that effect of child age genetically, right? And there's a lot of other evidence that is relevant to this, and including the animal research, right? If the proximal causes of these poverty-driven changes are things like stress, restricted linguistic doesn't work for animals, but restricted cognitive stimulation, and of course, environmental toxins, right? lead, other kinds of toxins in the environment, which poor kids are exposed to a lot more of than wealthier kids. These are clear environmental effects as shown by animal research. So it makes a strong argument for the plausibility in the human case of environmental causation. Okay, so basically, whether it's genetic or environmental or both, as it usually is, it has no implications for whether or not this information could be relevant to policy. And in fact, it's pretty clearly, at least in part, environmental. Okay, another part of the critique from Amy Wax, I'm not sure if Charles Murray has made this point or not, but in fact I have to confess that I made that when I first encountered this work, was, look, there's no unique practical payoff here, right? So I want to ask you, is that the relevant standard? For neuroscience to be relevant, does it have to be telling us something that we didn't already know from other sources? And so, I mean, honestly, this is something that I've said, which I now think, Martha, that was really kind of stupid and thoughtless. But what it was me being somebody raised as a scientist, raised in a scientific culture. If you're a scientist, what you care about is something that's new and surprising. You are doing hypothesis testing. You want a significant effect that hasn't been found before, or a significant effect that shows some new wrinkle in something that hasn't been found before. But you know what? The last thing you want if you're designing policy is like one singular result to drive your work, right? You want to formulate your policy based on the weight of evidence. And it turns out there's a whole literature on weight of evidence, or WOE, which is very different from the way scientists think. And it's typically used in a sort of informal way. It's a kind of almost qualitative aggregation of things that we know from lots of different sources. And it actually gives extra value to evidence that comes from qualitatively different sources. So in fact, it's not a problem that neuroscience is showing us things like stress is bad for young children. It's actually a plus. It's like, good, now we have yet another converging piece of evidence for this. So I think that, this idea that it needs to earn its keep in the world of policy, the science has to be giving us something really new and unexpected, is just silly, and it's based on a misunderstanding of what policymakers' decision-making is like, and how different that is from, all of us kind of pursuing the cover story in science as our research outcome. Okay, well, could neuroscience deliver unprecedented policy insight, right? So I've just said it doesn't have to be valuable. But in fact, I think it can. Maybe not right now, but I think in the foreseeable future it can. And let me just walk through a few of these kind of exercises in imagination for, which you can take or leave or take seriously or dismiss, because it is all speculation. But I think, for example, the moderation findings that I mentioned in the beginning, this idea that, for example, when low SES kids are doing arithmetic problems, this is work from a scientist named Denier, they tend to activate spatial parts of the brain. They activate parietal lobe regions, and how well they do at the math is correlated with how much parietal activation there is. And it's not correlated with activation in areas that are typically involved in verbal processing, like left inferior frontal gyrus, lateral temporal lobe areas on the left. Whereas when higher SES kids do math, they are more activating these verbal areas, and how well they do is correlated with how much verbal area activation they show, and not with how much parietal activation they show. And they've actually gone and done a study of math instruction, where they found that that same kind of double dissociation holds for gains after training. So the gains experienced by low SES kids are reflected in more parietal activation. Now, I maybe made this sound a little neater than it is, but not too much. This was very well done research, and it's pretty compelling. But if that's true, then that suggests that, math education that works well for low SES kids may not work so well for higher SES kids, and vice versa, right? So this may have implications for school curricula. And, when Stanford Ed School, rolls out a new curriculum for math education that has been tested on, local kids in the professors' kids, right? And it shows really helpful effects. Maybe that should not be taken into inner city schools. Maybe we should at least ask ourselves, it may not be valid for lower SES kids and vice versa. And there are similar findings with reading, with functional patterns of activation, and even with, DTI identified, measured pathways that correlate with reading differently in higher and lower SES. Okay. Here's another possible way that neuroscience could actually earn its keep and do something novel: biomarkers. Now, again, this is off in the future, and it's also not that exciting. I mean, just like a biomarker, it's just like an index of something, and yet, indexes, particularly that predict what's needed for education, for mental health care, could have huge practical use. And, yes, ultimately what we're interested in is people's behavior, but you know what? Despite, people sometimes saying, criticizing the neuroscience approach to non-medical problems and saying, look, if what you care about is behavior, then study the behavior, come up with behavioral interventions. Well, sometimes it's harder to get a sort of a feasible sample of behavior from somebody than it is to record a little EEG, right? So behavioral prediction with brain measures is not simple, and people have made lots of mistakes. Russ Holdrak, one of your colleagues here, just recently wrote a very interesting paper critiquing, sort of showing what the problems have been in predicting criminal behavior with brain measures, but also laying out, this is what you would need to do, and then you could properly do it. So this could be useful, especially early in life, when kids are not able to perform a complex task. They can't follow instructions. They may not even be able to talk to you. The brain markers could be useful. Windows of opportunity for protecting brain development. Prenatally is when the sort of basic architecture of the brain is set up. And we are learning more and more, both in animals and in humans, using amazing stuff, fetal fMRI and so forth, about how that process works, where it can be derailed, and even like specific timing, like stress is more harmful in this trimester than in that trimester. There are such studies. So now, trying to make the world a better place for somebody's lifetime may be a tall order. Trying to reduce stress and improve nutrition during a certain trimester, that's much easier to do and might therefore be a worthwhile policy goal. Farther out, you can think of real kind of mad scientist stuff, but yesterday's mad sciences, today's really helpful new technologies. People like Takao Hench are finding ways to open and close critical periods. There's epigenetics, studying it, manipulating it, etc. Microbiome. Who knows? There are SES differences in the microbiome. Okay, and this is just an example that I love, making that point, that yesterday's, kind of silly blue sky science is tomorrow's, really important improvements to human life. William Gladstone saw Michael Faraday, demonstrating, induction of a magnetic field with an electric current, or maybe it was vice versa, anyway. And he said, what good is this? You're wasting your time. You're playing with toys. Do something useful. And of course, this is what gives us the electric motor. So, final set of thoughts. Should neuroscience inform policy? I mean, I hope what I have said to you is, look, the door. Let's open that door a little bit to the feasibility. It actually could be useful, but there are a slew of criticisms from very far left academic sociologists saying that really this train is like one stop away from eugenics and going fast towards that station. And it's not just eugenics. So it's been said, actually, these papers are actually beautifully written, even if they're kind of frustratingly, overstating things. One guy says, Lindy, the neuroscience approach to poverty is like saying slavery is morally wrong because it impacts brains, Okay, I don't think it's really like that, but I do think it's important to recognize that the work that we're doing in neuroscience is separate from, we're doing ISs, they're doing lots. Okay. It also misplaces the blame. I mean, I don't think we have to be in the game of placing blame. But I think there is a valid point here, which is that we got to make sure that in the focus on individuals' brains, we don't lose sight of the larger structural aspects of society that are the sort of ultimate causes of these brain changes. And it would be very sad, if, can I have 2 more minutes? It would be very sad if this neuroscience work led us in that direction. Neuroscience, especially the emphasis on prefrontal development and language, is value-laden. It's a very middle-class set of values. It is, I have learned from these lefty sociologists, associated with the neoliberal, sort of values of what a person should be. And Foucault gets in there somewhere too, but because I'm out of time, I'll be saved by that bell. Neuroscience medicalizes and really could go on to pathologizing poverty. And the emphasis on critical periods, it encourages a kind of fatalism, like, well, this child is 5 years old. They've missed the boat. They're damaged goods. Forget about them. Right? We wouldn't want that. Now, I want to just very briefly mention the fatalism, the emphasis on starting early, is very prominent in the sort of pro-neuroscience and policy literature, and has been used to argue for the importance of funding early childhood programs and parent training. The Frameworks Institute, it's a communication sciences program, and they basically help political, social causes find the right language to frame their agendas in that will evoke a more friendly, agreeable response from the public. So they talk about the importance of brain development and fostering it and so forth, because that seems more acceptable in a country like ours, where it's everybody like, your life is your own responsibility, your kids are your responsibility, etc. It seems a more friendly notion. And this is a report from the Center for the Developing Child at Harvard, which really comes on strong about what neuroscience tells us about what child policy needs to do. And it's all about framing. Okay, conclusions. Neuroscience of SES is a young science. There's a lot we need to still sort out. But I think it's not really fair to accuse it of overreach. I think the most overreaching people, they're not really the scientists, and I think more and more careful, thoughtful work is coming out now, talking about how it could it could actually do more modest things. The framing, I think, really has led to some of that overreach appearance. Some of these, Bolshevik sociologists have raised valid criticisms. I think they're overstated, but I think we need to take them into account. Like, are we moving the discourse too far away from social changes that need to take place by talking about the brain? And I just want to say, like all science, this is a long game. We've got to play a long game. We have to proceed with patience to really figure out what's going on scientifically. We need to be mindful of the unintended consequences and pathologizing poor people. And we need to pursue social and economic change as well. And my last slide is to explain why I'm not sticking around for longer, because initially I was thinking, this is great, I'll come to Stanford, there's so many fantastic researchers here, I'll meet with them all. And then I got this puppy, and he needs me at home. It's like having a young baby. Right now my daughter's taking care of him, but it's really a two-person operation. So that is Cody, and that's why I'm flying back at the crack of dawn tomorrow to see. So thank you.
I appreciated your talk, and particularly the point you made in the distinction between science and policies, looking at the bulk of the evidence. So I'm wondering whether neuroscience might help in cases where there is not yet a bulk of evidence. So in new situations, in particular things like cognitive enhancement, new drugs that have not yet been around or even invented yet, would that be a place where the science might have more application to policy?
Yeah, I mean, well, I actually think it has application even, for something like, here's a policy that the American Academy of Pediatrics has considered, which is, do we ask parents who bring their kids in for a well-child checkup, do we ask them about their stress levels? And do we talk to them about stress reduction, stress management strategies, right? And there's clearly pros and cons, because that's taking up clinical time, et cetera, et cetera. There's already really good evidence, behavioral evidence, that stressed out parents do less well by their kids, and their kids suffer from it, and their kids don't develop as well. But I think having an additional chunk of evidence to put on that growing pile of evidence absolutely says, yeah, even though it takes away clinical time, even though you might not be able to see quite as many patients in a day, that's worthwhile. So I did want to, just to clarify, I do think that the weight of evidence that's used in policymaking always has room for a new source of evidence like neuroscience. But I also agree that there are some unique ways that neuroscience may offer new insights, including these neuropsychiatric drugs that Ryan uses. No, mentioned. Okay. Is my time up, or should I?
So, wondering.
Thank you.
So I study psychosis and brain functioning, and when we look at SES, we actually look at parental SES, because the illness interferes with educational attainment. So I was wondering if, and you probably do, but if you look at parental SES on brain development and how that shows up or impacts things.
Yeah, that is a great question. Childhood SES, which is basically measured by the parents' SES, or the home in which the kid's growing up, is a very powerful predictor of lifelong health and lifelong cognitive functioning. Concurrent SES in adulthood is also influential, but among the things that have to be sort of picked apart and understood going forward is the distinct influences of childhood and adulthood SES. But childhood SES leaves a mark, a lifelong mark on brain function. Oh, okay.
Hi. So I had sort of a question about the other sort of relationship. So how?
There he is.
So how policy itself can sort of affect some of these outcomes for folks experiencing like a lower socioeconomic situation. So thinking about how we impose sort of the onus on poorer people. So for example, kids getting stressed out because their mom is yelling at them because they keep forgetting to bring home the form for free school lunch, or hunting down this specific 20-ounce jar of peanut butter that your WIC check will cover, and things like that. So how can we use neuroscience to sort of find better policy solutions than are already sort of attempting to help?
Okay, well, the sort of level of sort of interventions I think that you're talking about there are more like sort of day-to-day life, making systems easier to manage and navigate. Probably firing all the insurance navigators is not the right way to do that. The best thought-out work that I know of on this is from behavioral economics, not really from neuroscience, but they're closely intertwined. And it has to do with the concept of nudges, and just making it less of lowering the barriers that you have to get over to just sign up for programs and remember to do what you need to do. Absolutely. There are also some very interesting studies that use a sort of natural experiment design where suddenly, for reasons that have nothing to do with the individuals involved, some individuals get a new benefit, get a new state benefit. And with those, we can then look at the way that children develop. And I know surface area, cortical thickness, volumes of various important subcortical structures. It's probably too early to make any really firm generalizations, but I think a reasonable working hypothesis is that you see the biggest effects in areas that are typically involved in executive function, emotion regulation, and language. Functional differences, striking functional differences that have been looked at the network level, as well as more traditional blobs, fMRI, where's the blob designs. We see differences in cognitive patterns of activation during cognitive processes, patterns of activation when people are processing emotional stimuli. A very sad generalization that can be made at this point about the data is that lower SES people activate the relevant brain areas less strongly to positive stimuli and more strongly to negative stimuli. That's true with your standard IAPS pictures, for those of you who do this kind of work. It's true for emotional faces. It's even true for new mothers looking at pictures of babies. And if they're looking at pictures of happy babies, you get more activity in reward centers for the higher SES moms. And if it's looking at pictures of crying babies, fussy babies, you get more activation in the amygdala and other areas in the low SES moms. There are effects that you see early in life. We did a study imaging 1-month-olds, looking at volume of cortical gray matter. And to our surprise, we found differences. This was supposed to be the first phase of a longitudinal study where we thought we were going to see the differences emerge. It's called our attention to the importance of the prenatal period. And I mean, some of you were like, of course, the prenatal period. To me, trained in psychology, we sort of begin with the kid when they come out, But it turns out there's very good data from animals and humans showing that prenatal environmental influences shape the brain throughout life. So that's the picture at the most descriptive level, okay? And I am frank and humble about saying this is just descriptive, which is not the most exciting science, but it's the place you got to start. Let's see, Hewlins Jackson has a wonderful quote. He said, the study of the causes of things must be preceded by the study of the things caused. So I am kind of unapologetically saying, yeah, we've got a lot of descriptive research here, and we need that. We also have some more mechanistic, some research going on that looks more at SES and the brain in the context of the larger causal fabric of environment, life outcomes, etc. So there's the mediation question. Do these brain differences that we see account for outcome differences? Do they mediate the different life outcomes, mental health, cognitive attainment, etc.? And I don't want to overstate how much research we have to point to here, but there is research, and some of it fails to test mediation hypotheses and does not find mediation. Some of it tests them and does. Enough do that I think we can conclude, yeah, this isn't like starting a butterfly collection, right? Like, let's have pretty butterflies in our little display case. Let's find interesting, differences in brain structure as a function of SES. No, these differences do predict actual life outcomes that we care about. So that tells you something about the significance, not statistical significance, but real-world significance of these differences. That's the mediation question. And finally, moderation. Moderation refers to the effect of a variable, in this case SES, on a relationship between two other variables. So it turns out, not that anybody was particularly looking for this, but repeatedly people have stumbled over the fact that the relations that we find between brain structure or function and abilities or, psychological characteristics are moderated by SES. That is, if you want to predict somebody's ability or somebody's performance in a task by looking at their brain structure or function, you need to look at different things for higher and lower SES subjects. There's like a qualitative difference in the way people are using their brains at lower and higher SES. Again, nobody set out asking the question, I wonder if it's a moderator, but this does appear over and over. So that's interesting, and that's part of the emerging literature that I am, with apologies, not telling you much about. And then finally, I want to tell you that the questions that we really care about as scientists are the mechanism questions, right? Like, what causes what? At what stages of development? By what pathways? And, what specifically can we find out by studying humans and by studying animals? So animals don't have socioeconomic status, they don't have occupational prestige and things like that. But they have many of what we believe are the proximal causes of differences between low and higher SES people, okay? So we can manipulate the stress that animals experience early in life, later in life. We can manipulate the cognitive stimulation, the variety of environments that they are allowed to spend time in and so forth. So this kind of research has also been useful for trying to understand the mechanisms by which SES impacts the brain. In fact, there's even a more fundamental question in the what causes what department, which is, are these caused by environment at all? Are these brain differences caused by environment? Okay. So it is possible that it's genes that are causing both SES differences, less able to get and hold a job, less able to get an education, whatever, and that cause the brain differences. In which case, their correlation is sort of spurious in a way. It certainly means we can't just automatically say, talk about how SES causes these brain differences. But I will return to that because that is one of the issues that comes up front and center when we talk about applying the neuroscience of SES to policy. And not the current issue of Neuron, but the one before, has a review article that I wrote. So if this little summary has left you sort of craving more detail, more specifics, I can direct you to that, where I just tried to lay it all out. Okay. Right now, what can we say about the field of the neuroscience of SES? I don't want to